Hello, greetings. I welcome you all to this particular lesson. So we've got this particular question that is here. So this is a 2023 science, which is physics O levels, section C. So I want to teach you how you get to answer this particular question in an easy way without facing any challenges. As you can see, the whole question is carrying 10 marks and you can't afford to miss all the 10 marks. Table C1.1 shows a force N and acceleration meter per second squared of a box recorded while being pushed along a horizontal surface by a learner. This is a table that is given. Then the first question is saying define force. This was a simplest question and I don't expect anyone to fail. Whenever we are talking about force, so I'll use a pen so that we try to understand this clearly. Those of you under my lessons, I gave you this question as an exercise and I'm yet to mark. So define a force. What is a force? You need to understand that a force, we are talking about a pull or what? It is a pull or push. So we say this is a pull or push that can do what? That can change. So we say that can do what? That can change. So we say that can change an object's what? An object's state of rest or motion. So that can change an object's what? State of motion. So I will say an object's state of what? State of motion. So it is a pull or push that can change an object state of motion. That is a force. That's why we usually say force is just a pull or push on an object. We now move on to the next question that is saying state Newton's second law of motion. So when you are taught to state Newton's second law of motion, you just need to say that this states that, so Newton's second law of motion states that the net force, so these are the answers. You just say the net force on an object. So the net force on an object, so I'm just summarizing this. The net force on an object is what? Is equal, so I'm going to say that is equal to what? The net force on an object is equal to what? Is equal to, so I'm going to say is equal to the what? Is equal to the mass. So is equal to the mass of the object, equal to the mass of the what? Mass of the object. So mass of the object multiplied by what? I'll say multiplied by acceleration, multiplied by its what? Its acceleration. So there is a keyword here, multiplied by its what? Its acceleration. So this is how we get to define Newton's second law of motion. There is Newton's first law of motion, which states that for any object that is at rest, it will continue to stay at rest not until an external force is applied to it. If it is moving, it will continue to move in a straight line until there is an external force. So that is Newton's first law. There is also third law that you need to understand. That states that for every action, there is always an equal and opposite force that gets to be applied there. So these are some of the things that you are supposed to understand. These, they just carry a mark. We go now to this main question that is here. So when you fail to get these 4 marks, it means that even answering these questions will become a challenge. So plot on a graph paper, a graph of what? A graph of force against acceleration. So you get your graph paper. So follow me clearly. You get your graph paper like this. So I'm using a pen, but you know that in an exam, any graph work, you are supposed to use a pencil. So you divide it, you get this, you divide it. So what I'm going to do is this. So I write my title here. This is a what? I'm going to say this is a graph. You know that if you write in capital letters, you are not supposed to do what? If you write in capital letters, you are not supposed to underline this. So graph of what? I'm going to say graph of what? Graph of force. So this is what I'm saying. Graph of force against what? Against acceleration. So this is graph of force against what? Against acceleration. So this is what I need to do against the acceleration. So against the acceleration, I do this. So I'm just supposed to do this. So this is the first step. Like I've told you, I said that we like I do this. I put some lines here. This, I do this. So this is what I'm going to do like this. So have you seen? I just leave like a box down there. So I do this. Even here, down here, I also do the same. So I even do, this is what you are supposed to do. So this is what you need to do. So you even do this. This is what you are supposed to do like this. And then you know that you need to do this. This is the x-axis. Then you even know that this one that is here, this is the y-axis. So that is the what? That is the y-axis. From here now, the other thing now, we get a question. This is a question. So we now get our question. This is a question that we have, and this is a table. Have you seen a graph of force against acceleration? So graph of force, have you seen force? So meaning this one against acceleration. So this is the x-axis and this is the y-axis. They are saying against the what? Acceleration. So against acceleration, this is to tell you that acceleration is on the what? X-axis. So this is what you need to get. So at the moment they just say graph of force against acceleration. So against what is given, that thing that is given is supposed to be on the x-axis. So this is a point. Some of you can say force is x, then acceleration is y-axis. You can miss the point. You can mostly we know mathematics there. These are key things you need to understand. From there now, what we need to do, we look at these. This is x-axis. Have you seen the way numbers are in the x-axis? 0, 1, 2, 3, 4, 5. So I can say, okay, in the x-axis, I can say 1 what? I can just say, okay, I'll just say 2 centimeters to represent 1 unit. So that is a scale. You can write it even somewhere. You can just say a scale there. You can say a scale there. So what you are supposed to do, you say 2 centimeters. 2 centimeters is representing how many? 1 unit. So 2 centimeters to represent 1 unit. You even put in brackets. That is what? X-axis, like this. You can even put numbers there. You go to the x-axis. This is the x-axis. This is 0. So 1 like this. Here 2. Here 3. Here 4, here I put what? 5. So I can end even up to 5 like that. So I know that here I get to have acceleration. So I put my acceleration there. So I say acceleration, which is what? Meter per second squared. That is acceleration. Then here I know that this is what? This is the y-axis. And there is force. So I say force. Force is in what? Force is in newtons. So I say force, which is in what? Newtons. Then I look at the way the y-axis. Have you seen the way these values are going? There is 0.5. Have you seen? I'm able to tell that, okay, this is 0.25, 0.5. So I can just say 2 centimeters to represent what? To represent what I'm going to do is that I'm going to say that it is going to represent what? 0.25. I can use that particular scale. So you can use a scale that you are comfortable with. So I can just say 2 centimeters is representing what? 0.25. So I'll just say 0.25 units. This is the what? This is the y-axis. I know that in the y-axis, I'll be moving by 0.25. So I say, okay, 0.25. I start. You know that the graph is supposed to be as big as possible like that. So if I say, okay, I can extend this. What if I say 4? So if I say 4, which means that I'll be moving like, okay, here, this is 0.5. this is like this. So I can say, okay, I can make it big like that, where I can say that, okay, what if I say 4 centimeters to make it big? 4 centimeters represent 0.25. So every 4 centimeters, which are 2 boxes, 1 to 2 boxes. This is where I've got 0.25 like that. From there, this is where I've got what? This is where I've got a 50. I mean 0.50 like this, 0.50 like that. And then there, this is where I've got what? This is where I've got 0.75 like that. Then there, this is where I've got 1. This is where I've got 1. So I say, okay, this is where I've got 1. Then there, this point that is here, this is where I've got 1.25. I can put it to be like that. I can put my graph to be like that. As simple as that. So have you seen the way my graph is? This is how your graph is supposed to be. The same way it is like this one. So I've got the x-axis and the y-axis. I start plotting. So I need to start now doing what? The plotting should start now. So how am I going to start? I get this. Then what am I going to do? I check. The first point is 0,0. Have you seen 0,0? So I say 0,0 is just here. 0,0, it is just there. Then the next one is what? 1, 0.25. So 1 is here, 2, 0.25, it is there. So the point is going to be there. This is how I'm going to put it like this. Then I move to the other one, 2, then 0.50. Have you seen 0.50? So 2, 0.50, it is here. This is what I'm going to do. Okay. Then I move to the other one. I go to 3. So 3, 0.76. 3 is here. 7 is there. Have you seen 7 is there? Then 6, I just put a 1 box there. So just put a 1 box so it will pass through there. So I'll just say it is going to pass through there. Then I move to the other one, 4, 1. So 4 is here. Then where is 1? 1 is there. This is what I need to do. Then the last one, 5, then 1.25. 5 is here. This is where I've got my 5. Then 25, 1.25 is there. So this is how my graph is. I don't know if people are able to see. Let me try to do this. I don't know if people are able to see like this. It is like this. So if you are following, you need to put a ruler like this. You put a what? You put a ruler. So if you put a ruler, you discover that you are able to join all these points, isn't it? You are able to do what? You are able to join all these points. It is a straight line. So you are able to join them like this. You are able to do what? You are able to join them. This is it. So this is how you are supposed to do it. If you are following closely, you are going to understand. This is what you are supposed to do it. Just like this. So this is a what? This is a graph. So they give you how many marks? They are going to give you about 4 marks. Just like this. There is a title. I've labeled this scale and this is drawn neatly like this. I guess you are able to see how this is. Like this. I'm done. I proceed now to the next question. I go to the next question now. So to the next question, here I'm done with this one. I move to this one. They are telling me to say, determine the gradient of the what? Gradient of the, I'm told to determine the gradient of the graph. How do we determine the gradient of the graph? This is D. So I can indicate here D. I want to find what? Gradient. How do you find the gradient? You can get to any 2 points. So I can get a point that is here. Have you seen this point that is here? This is what? 1,0.25. The point that is here. This is 0.25. That is a point. And I get another one. I'm just getting simple ones. I can get this one if I want. If I want, I can get that one. So I can go with this one. this and at least there is a gap, but the answer will still be the same. We know that gradient is the same as long as 2 points are lying on the same line. So I can get that one. That is 4,1. At least this one, no points. 4,1. I do that. So I need to find gradient. You know gradient is found by saying y2 minus y1 over x2 minus x1. You know that this one is x1, this is y1. This is x2, this is y2. This is it. From there now, what you are supposed to do, I guess you are following. I guess you are now following what I'm doing. From there now, you say this is now equal to what? It is now equal to what? I say, what is my x2? That is 1 minus x1, I mean y1. Y1, this is 0. What? Y1, that is 0.25. I do that. Over. Then y2, that is 4 minus, I mean x2, that is 4. x1, that is 1. So this is what I'm doing there. So I say gradient is now equal to, I get my calculator. So I say, what is the 1 minus 0.25? What is the answer? The answer that I'm getting is 0.75 over, what is 4 minus 1? It is 3. So what is the answer there? I try to divide. So the same answer that is showing, I divide it by 3. This answer divided by 3, you are going to get 0.25. This is your gradient. You are done with that question. This is the what? This is the gradient. Then we go and check the next question. We've answered this question. The gradient is 0.25. I've shown you how to answer it. We proceed to this one. What physical, have you seen this question? What physical quantity does the gradient represent? According to this, you need to understand that the gradient represents what? You say gradient represents mass. So it represents what? It represents, so you say it represents the mass. So you say it represents what? The mass. You are done. Gradient is representing the what? The mass. We now go to the last question. The last question is saying, from the graph, determine the force that produced an acceleration of what? This acceleration. So determine the what? The force. What you need to do here, you need to say force is equal to mass times acceleration. What is the mass? The mass is the same like I've told you. So the mass will be what? This same mass that is there, 0.25 times the what is the acceleration? This is the acceleration that is given, 3.5. So what is the answer there? When we multiply, what answer are we getting? So when you say 0.25 times 3.5, what answer are you getting? You are getting 0.875. Then you just conclude and say, therefore, the force that produced an acceleration, so you say the force that did what? That produced, so the force that produced an acceleration, so that produced an acceleration, the force that produced an acceleration of what? An acceleration of 3.5 meter per second squared is what? 0.88 newtons. So 0.88 newtons. This is the answer. So these are the answers that I was expecting from everyone, those of you under my online lessons. So I've just made this public so that we can revise through together. So those of you, since this is a public video, so some of you that have not joined me or you could like to join my online lessons, I get to do this at an affordable fee. For science, you get to pay 100 kwacha, both chemistry, physics, that is to the Zambian syllabus. But those of you from other countries, you pay separate. So here you say, okay, this is my number, my WhatsApp number. So you get to WhatsApp me on this particular number if you want tuitions. So this is my number. And this is 2025. These are the fees. You know, the fees get to adjust. So at the moment, it's 100 kwacha per subject, Zambian kwacha. This is where we get to earn from. I guess you've learned one or two things. Another advice, when you're answering these, some of you are having questions like, how can I know that the answers I'm supposed to write them here, or am I supposed to put them on the graph? What is important is numbering your work. So in the answer booklet, you say section C, C1. Then A, you write that one. These, the ones that you are able to write here, you write them there. The ones that you are able to write them here on the answer booklet, not like this. In the answer booklet, you are supposed to write them there. Have you seen? So the most important is numbering your work. You need to know how to number your work. So this is where we get to earn from. Thank you so much for watching this video. And I guess you've learned one or two things. Thank you. Don't forget to like. Don't forget to comment. Don't forget to subscribe to this wonderful channel. Thank you so much.